This is a breadboard, and in this video I'm going to show you how to make connections between electrical components using a breadboard. So the purpose of a breadboard is to allow you to connect electrical components together using jumper wires without having to solder the components to a circuit board. Let's take a look at how the holes of a breadboard connect together electrically. The holes of a breadboard are spaced such that you can insert these kinds of integrated circuits or chips into the breadboard and make connections. So I can press an integrated circuit into this breadboard like this, where the pins go into the holes, and now you can make electrical connections to those pins. Integrated circuits are inserted so that the pins are on either side of this valley right here. So the way these holes are connected together electrically is like this. All of the holes along a row are connected together electrically. So this pin, this upper left pin, which is pin 1 of this integrated circuit, is connected to the holes to the left. There is an electrical break at this valley so that this row, this 1, 2, 3, 4, 5, these 5 holes are isolated electrically from the holes along the same row on the other side of this valley. So there's no electrical connection between this left row right here and this right row. So if I want to connect a wire to pin 1 of this integrated circuit, where pin 1 is the upper left pin of this integrated circuit, all I need to do is take a wire, this is a jumper wire, and insert it into a hole that is along the row that is also connected to pin 1. So this orange wire now connects to pin 1 of that integrated circuit. The rows are isolated, so this row connected to pin 1 is isolated electrically. It's not connected to the row along pin 2. So if I would like to connect pin 1 to pin 2 of this integrated circuit, all I need to do is insert this orange wire into a hole along the row that connects to pin 2. So there I've made a connection between pin 1 and pin 2. So this pin numbering starts at the upper left for this integrated circuit. You can see kind of a notch up here that indicates the pin 1 side. To the left of that notch is pin 1. I can count down 1, 2, 3, 4, 5, 6, 7. So this is pin 7. This is pin 8, 9, 10, 11, 12, 13, 14. So the upper right pin is pin 14. If I want to connect, let's say, a resistor, here's a resistor. If I want to connect this resistor to pin 7, all I need to do is insert the resistor into a hole along that row. So now that resistor, one side of it anyway, is connected to pin 7. So with this breadboard oriented the way it is, it's pretty common for breadboards to have columns of connections also, kind of on the outside of this area where you insert chips. And usually the purpose of these columns of connections is to apply power to your chip. So you could, for example, along the left side here, along this whole column where all these holes are connected, this column could be a 5-volt node, and then to the right of that you might, along this blue column here, apply ground. And so you could connect the 5 volts and ground using wires jumping over to your chip. So these holes in this region here have different types of connections compared to the holes along the outer edges of these breadboards. So let's put this all together. Here is a different breadboard. You can see that the holes and the valleys are oriented actually 90 degrees from the breadboard I was just showing you. But let me actually put blue circles, blue outlines around all of the holes that are electrically connected together. So now you can see what holes are actually connected together. You can see the valley along the center here, horizontally in this case, and then these sets of pins are all connected together so that you could put a chip horizontally across this valley and get make connections to the pins of the chip. Here are the power connections that I talked about. In this case, they're horizontal instead of vertical, but you can see that all of these pins along the top are connected together. There's actually a break here, and many breadboards have this. There's kind of a break, so if you wanted one in this case, row across the top that was all connected together, you'd actually have to put a wire across two holes here to connect the two groups. And so on the left here, you can see here's a column of connections. These are all connected together. So it really depends on the breadboard. You really, to figure it out for sure, you have to take an ohm meter and check if holes are connected together. But once you figure it out for one breadboard, it's pretty easy to get used to. So your breadboard might have these terminals, these screw terminals, and you could connect wires to these terminals in order to make connections to your breadboard. These terminals on this breadboard actually have no connection between the terminals and the breadboard. You actually have to take a wire and connect these terminals to nodes on the breadboard in order to make those connections. But it's a convenient way. If you have banana plugs, you could plug them right into the tops of these terminals and then run wires from the screw terminals over to the breadboard nodes. So let's suppose I just want to make a connection between two wires. What I could do, let's say come from pin 3 of this integrated circuit down here to kind of an unused part of the breadboard, and then I want to take maybe this yellow wire and connect it to that red wire. All I need to do is plug that yellow wire into the same row that red wire is connected to, and now I have a connection between the red wire and the yellow wire. And maybe I want to make a connection back up to this chip. Let's connect to pin 8 of this chip. So now the red wire is connected to pin 3 of this chip. The red wire is connected to the yellow wire, and the yellow wire is connected to pin 8. So effectively, pin 3 is now connected to pin 8 of this chip. So that is basically how connections are made on a breadboard.